I made a new transformer out of a microwave oven core. I kept the low voltage thick wires here. These equal 1 ohm. And these are 22 gauge, and it's about 8.2 ohms. I wanted 10 to 1, but for now this is good enough. I can add more wines, take off more wines. And this is my old one I've been using. If I short this out with an ammeter, the most I can get is 420 milliamps if I just short out the secondary with an ammeter. These both draw the same, and what I'm doing, is I hook them in series to the L3 line. And but this one, if I short this one out with a 4 UF run cap, it's 1.3 amps. So it's almost 3 times more amperage this thing creates. And I know that this inverter, right now I have it looped, and I'm running the motor off the inverter. The inverter runs from this battery in this supercap bank. And I know that if I have no load and I just run this thing with this little stat power inverter, it takes 540 milliamps. Okay, but right now, there's more going on, and let's see what it draws. I have it in DC amps from the battery to the positive of positives of everything. Positive of the four-way bridge coming in, the positive of the supercap bank, and the positive of the inverter. So this is like everything between just what's coming out of the battery. What does it take? So here we go. I'm testing the amperage in DC. And there's kind of the base, but watch how it grows. Not sure what that means, and I'm wondering, here, I'll do it again. I'll connect it, now I'll pull it off. See how it gets more and more? I'm wondering if there's kind of a clash in current directions, and the full wave bridge is trying to fill stuff up, but there's current going the other way, causing the draw to go up. It stops right there. Let's do that again. Just connect it. Connect it, take it off. This might be the supercap bank and the battery kind of leveling itself out, or it might be some clash in currents. Not sure. So let's isolate only the only what goes into the inverter right now. So one moment. Wow. Here's my problem. why I can't just run this thing on super caps is this inverter. This is the hot wire positive to the inverter, and I'm testing it coming off of the battery positive. So this is what the amperage is that the inverter requires. Look at that. That's a lot of amps. This is the supercap bank connected to the battery, and the inverter's pulling 1.79 amps, 1.8 amps. Wow. I'm going to disconnect the full-wave bridge rectifier. That's right here. Disconnected. Wow, see? Look at that. I disconnected the full-wave bridge rectifier that's supposed to be keeping everything stocked up. It's supposed to be supplying current there. And when I take that off, the draw between the inverter right here and the batteries and supercaps drops all the way to 0.89. So this kind of indicates that there is a clash of the titans going on in current. See, look, I'll connect the full-wave bridge down here. And when I do, the draw goes up almost a whole amp. That's what's being pulled from the batteries. See that? I think Bedini was saying you can't pull from a battery and charge it at the same time. But I suppose you can if you have tons and tons of current. If I had 2 amps of current going in here, it should keep the battery charged. But I don't. I have 780 milliamps of current showing from the full-wave bridge into here. You know what I think? I think I need some sort of a switch system. Like maybe once a revolution of the motor, it connects only the full-wave bridge to charge, and then that's disconnected, and then the switch connects the inverter to power the motor. It's like one or the other idea. Okay, well, maybe someone out there has some insights. And sorry about my last video, it was embarrassing. I had the ammeter at the wrong place, and I thought it was not drawing anymore because the tone of the engine didn't change, but it was. Right now, if anyone's wondering, it's drawing 189 milliamps, quite a bit with this new transformer. So I think I might need even a bigger transformer. So, okay, well, I got one improvement. This can, with a 4 UF run cap, this pumps in 780 milliamps. And with the same run cap and the same series connection to the run cap phase, this can supply only 340 milliamps, all things the same. Okay, well, there's my experiments for the day. Thanks for watching.